Continuing through the Edexcel higher tier paper 2 from 2020, we're on question 16 and we're told that we've got the first 5 terms of a quadratic sequence. So a quadratic sequence, if we're looking for the nth term, is going to be something like this. So the nth term will equal a n squared plus b times n plus c. And what that is a, b and c are all numbers that we've got to find. So as an example, which wouldn't be this one, but we could have something like this, plus 2n plus 1. Now that's not going to be it because we've actually got to find these numbers, but that's an example of a quadratic sequence. So we need to try and find those. Now what we can do, if we start off again, I'm just going to write the sequence, just give myself a bit of space. We can look at the differences between them. So if we do, we can see that we've got 11, and then the next one is 17, and then the next jump from 38 to 61 is 23, and the next jump from 61 to 90 is 29. And then if we look at the second row differences, so this time these should all be the same if we've got a quadratic sequence. You can see that goes up by 6, that goes up by 6, and that goes up by 6. And whatever that number is, provided it's the same number all the way along, then actually that's equal to twice whatever a is. To find the coefficient there, we know that 2a equals 6, so actually we've got that a is equal to 3 because we're just dividing by 2. So we've got part of it now. The next thing we can do is, in fact, there's a little formula. So the first term in the sequence there is actually equal to a plus b plus c. So that's something we can remember there, that the first term in the quadratic sequence is actually just equal to the coefficients added together. And there's another nice little trick. I'm just going to change colour pen just so we can sort of see what we're doing here. We can go backwards. So we could say, well, if we went to the term before, then we'd be again, that would be 6, so we would have added 5, because I'm going to take away 6 from this one. That's going to give me 5, and then that means that this term here would have been 5 if we'd gone back. We could call this the 0 term. So that's the 0 term, that's the first term, second term, third term, etc. So that 0 term is always equal to c in the sequence. So we've got 2 of them already. We've got that c is equal to 5. Now, because we know that a plus b plus c equals 10, and we know the value of a and we know the value of c, it's quite easy for us now to find the value of b. So I can say, well, replacing a by 3, and then I've just got the b that I want to find, plus 5 equals 10. So then what I'll get is a plus b equals 10. Got b equals 2. So now I'm just going to put the values into there. So I can see, well, okay, so a is 3, so I've got 3n squared. B is 2, so it's 2n, and c is equal to 5. So that's the nth term there. And that allows me to find any value within the sequence. So if we applied that formula to, let's say, we want to find the third value there, so 38, all I'd need to do is say, well, the third term is when n is equal to 3. But I have 3 times 3 squared plus 2 times 3 plus 5, and that's equal to 3 times 9 plus 2 times 3, 6, plus 5. So that's 27 plus 6 plus 5. And if we add those together, we do get 38, which is correct because that was the third value in the sequence. There we go. And the reason I've done that, we didn't actually have to do this last bit here. We didn't actually have to do this substitution, but it's a useful check. We can check that our formula is correct. So if you're in an exam and you have time and you've come up with this formula here, which that could be your final point of your question, but if you've got time, you can actually just check the answer that you've got and see if it does give you one of the terms in the sequence. So I hope that's been helpful, and if it has, please consider subscribing to our channel and also giving the video a thumbs up. Thanks for watching.